أنا فكر الأربعاء بقول كيف الساينس عندنا أول حصة.
طيب open your books. Open your book,
Mister?
page.
Mister, is the exam going to be multiple choice?
Most of the questions, yes, multiple choice, but of course there are other questions that need.
So on paper or what?
I will send it to you for you by WhatsApp.
On paper, we have
Yes.
to
You
write
can,
it or
يعني, you write the answers. والله who's talking?
محمد تعمل الناس في هذا فويس خلاص اسكت.
حسام شو
اعمل له ميوت أستاذ، اعمل له ميوت.
طيب. This is the last class in this semester, in the first semester. As we mentioned yesterday, that energy is conserved according to the law of conservation of energy. This principle states that energy is never created or destroyed, but only can change from one form to another. Like when we say that the law of conservation of matter is never created or destroyed, the same thing for energy never created or destroyed. What does this mean? That when any object in this universe loses energy, this energy is gained by another object. The energy will not disappear. This is the meaning of energy conservation. And also the total amount of energy is the same. For example, if energy is changed from one form to another, the total energy stays the same, but it is changed to another form. I mean, if you, for example, eat a piece of cake, okay, and the amount of energy, for example, in this piece of cake is 100 calories, okay? So your body change the chemical energy or the energy of this piece of cake into heat, for example, and kinetic energy. The total amount of the heat plus kinetic energy must equal 100 calories. So the energy is never created or destroyed. The total amount of energy is the same. And also, whenever one object, if one object loses energy, okay, this energy must be gained by another object. يعني when an object loses, أيوة راشد, wait, when one object loses energy, this energy is will not disappear. It only gained by another object. طيب أنا عملت لكم ميوت عشان الصوت اللي طلع. طب يلا. What do you want to say, Rashid? What do you have?
Mister, all the time heat plus kinetic energy equals 100?
No, it is just example.
Oh, so okay, I understand.
I have to tell you that the amount of energy will stay the same. طيب. Okay, what is the meaning that energy, the law of conservation? There is a certain amount of energy in the universe. What is the meaning of universe, by the way? The universe is not Earth. Universe is larger than the Earth. We mean by the universe all.
يعني كل الشمس والأرض
Excellent. Not and only the universe, not only the solar system. All stars or galaxies, everything that is
Everything.
yes, everything that is created by Allah. Okay, the universe, something that we can't imagine. It's very huge. Okay. There is a certain amount of energy in the universe and we cannot make more of it. This is simply, and you can understand the law of conservation of energy, that we can't make more of energy or destroy any that already exist. Matter or energy, anything, matter or energy, both of them are conserved. You can't make more and also you can't destroy anything. Right. Another way to state this idea is to say that energy is conserved. Always energy is conserved. When one object loses energy, others or other objects must gain it. يعني when an object loses
It can't
energy,
be destroyed.
نعم.
It can't be destroyed or fixed. It's equal.
Yes, when one object loses energy, this energy must gained by another object or other objects. This energy may go to one object or to other objects. Okay, طيب. When an object loses energy, it doesn't mean that this energy disappeared. طيب. This is known as the law of...
For example, when we eat cucumber, chemical energy, it transforms into from its energy to our energy.
Yes, of course. يعني you gain this energy. That is...
Yeah,
Yes.
doesn't go away.
Yes, of course. And if you remember the food chain also, a food chain is an example of that energy, or is an evidence. The food chain is an evidence that energy is conserved. For example, when the grass is eaten by a rabbit, okay, and a rabbit is eaten by a fox, for example, this is a food chain. As you remember, energy is transferred from the grass
From grass
to
to the
rabbit,
fox.
and the rabbit then to the fox, but the total amount of energy is the
It's
same.
the same.
Okay, طيب. Okay. One object loses energy, other objects must gain it. This is the law of conservation of energy. This law is a factor in both energy transfers and energy transformation. يعني this law is true or applied when energy transfers. What do you mean by energy transfers? Do you remember that when energy moves from an object to another? Please, you must distinguish between energy transfer and energy transformation. The law of conservation of energy is true in both cases. When energy moves from one object to another, or when energy transfers, and when energy transforms or changes from one form to another. Okay? So, like this. This is an example of energy transfer. The energy transferred from the rabbit, then to the fox. This is an energy transfer. Energy transformation, when energy moves from one form to another, for example, from potential to kinetic. Okay? This is called what? Shabab? When energy change from one form to another, this is called energy transformation.
Transform.
In both cases,
Yes.
Energy transformation or energy transfer, the law of conservation of energy is true.
أستاذ هذا هو درسنا.
Yes, this is another example. When a baseball is hit by a bat, figure 5.
Mister, is this coming in the exam?
نعم.
Is this coming in the exam?
This lesson, anything we take in this lesson is included in the exam. But يعني, for example, if we don't finish this page, it will not be included in the exam. But all of the lesson will be included except anything that we didn't cover. We don't cover.
Okay.
Get it?
Yes. Yeah. But Mister, the exam is going to be from the first page.
No, Rashid, I told you that the topic 1 is excluded.
So
Look,
topic 2 and topic 3.
Topic 2 and topic 3.
yes, topic 2
Okay.
plus
And topic 3.
topic 3. Okay, يعني topic 3, all of topic 3. But if we don't finish anything in lesson 4, this lesson, it's not included. طيب يعني anything that we don't finish, يعني for example, this page is included because we finished it, the law of conservation. Okay, طيب. This example, look at this example, the baseball. Okay, مين عمره لعبها هاي البيسبول؟ طيب when a
يا
baseball.
أستاذ عشان تنخزق عيني.
طيب when a baseball is hit by a bat, as in figure 5, وين هو البات؟ هذا هو صح؟ هذا اسمه ايش؟ bat. This is the baseball. Okay, what happens here? The ball flies through the air. The law of conservation of energy explains why it does not keep flying forever. Okay, why does not the baseball
Because gravity.
why does not keeping flying forever? Okay, the kinetic energy of the ball, because the baseball is moving, so it has kinetic energy. The kinetic energy of the ball transfers
To the air.
from يعني here the kinetic energy of the ball or the energy moves from one object to another, so it transfers. The kinetic energy of the ball transfers to the air from, so ball to air, so from object to object, transfers, moves to the air, and transforms also into thermal energy. So here, as you see, energy transfer and transformation happens at the same time. Okay. Okay, due to the force of friction, the kinetic energy of the baseball transforms into thermal energy. طيب, the more air particles there are, the more transfer there is. So more kinetic energy transfers to air when the air is dense. That is why baseball travels farther and faster at a baseball stadium in this place, Denver, Colorado, where the air is
لأنه
thinner.
فيهوش هاي هواء.
طيب.
لأنه بفوتوش هواء كثير.
نعم يا ليث.
لأنه بفوتوش هواء كثير كأنه.
اوكي صح. Yes, يعني in when if there are more air particles, the
راح تنتقل راح
yes,
تسوي
the
ترانسفير.
more transfer there is, the transfer of kinetic energy to the air if there are more air particles. When we say that there are more air particles, that means the air is more dense. طيب. Now in this stadium there are less air particles. Anyway, okay. This is just example. Don't worry about the details. That energy, you have to know that whenever energy transfers or transforms, the total amount of energy is will not change. Energy is conserved, never created or destroyed. This is also on this page. It's talking about the conservation of energy in transfers when moves from one object to another. Think back to the wrecking ball. Most of the kinetic energy in the moving ball is transferred to what? Directly to the wall. He is talking about what? This example.
هذيك الجرافة.
No, I think here.
الخابطة هاي هي.
أيوة, yes. طيب. Look at this example. Whenever, so most of the kinetic energy in the moving ball is transferred directly to the wall. Any energy not transferred is transformed into thermal energy of the ball and air. Any energy that not transferred is transformed into thermal energy of the ball and air or the sound energy of the ball hitting the wall. طيب. Energy is conserved in this example as it is in any example. Also, this is another example of energy on how energy is conserved. طيب. Look here, no matter how energy is transformed or transferred, no matter how much energy is transformed or transferred, the total amount of energy in a system does not change.
Will not change. Will not
Okay,
change.
this is the meaning of law of conservation. We want to solve this exercise to explain how energy is conserved. Okay, okay. طيب, wait a minute, please. Look at the exact exercise, please. طيب, read the question, Rashid. Read this question, please.
Yes, Mr.
يلا.
Where?
Human runs and air density.
For more than 20 years, Major League Baseball games played in Denver, Colorado, have featured a high percentage of home runs. The high altitude of Denver means the air there is less dense than in lower altitude locations.
I will stop. Stop a minute. I want to tell you something that areas that lie with high latitude. What is the meaning of a high altitude? What is the meaning of lower altitude? For example, Irbid. The latitude of Irbid is 650 meters above sea level. Okay?
Yeah, exactly.
This is the altitude. Ajloon, for example. Ajloon, do you know where is Ajloon? Okay. Ajloon is almost
500 meters above sea level.
1,000 meters above sea level. So, yes, okay. Ajloon is higher. The altitude of Ajloon is higher than Irbid. Okay. So, areas or mountain areas or hilly areas have high altitude. And as you go up in the atmosphere, there are less air particles. Okay, so where is air more dense? In Irbid or Ajloon, the air is denser.
In Ajloon.
Yes, no, in Irbid.
denser. فكرت لسه.
Okay,
Because
as you go,
when the altitude is higher, it's less air particles.
Yes, that's
so
right.
there's
Thank you.
Pressure.
Yes,
but
fine. Look here, the high altitude of Denver means the air there is less dense. So higher altitude, the air is less dense. Lower altitude means the air more dense. Yalla. Again, Rashid, read from here the higher altitude.
The high altitude of Denver means the air there is less dense than in lower altitude locations. Suppose flying through the air in Denver do not transfer as much energy to the air.
Excellent. Stop away. So in areas where the air is less dense, that means there are less air resistance. There is less friction. When there are less air particles, when the air is less dense, that means when you throw a ball, there is less friction or less air resistance. Continue. So,
yes.
So balls
flying through the air in Denver do not transfer as much energy to the air. They keep that kinetic energy and travel further than they do in other ballparks.
Exactly.
This table shows how many home runs the Colorado Rockies baseball team hit at home and away over 10 seasons.
طيب شو يعني على فكره انا ما بعرفش باللعبه هي كثير الهوم اللي بيرموا الطابه صح والاوي
I think so. I'm not sure actually. I'm not really interested in these stuff.
well me too I'm not interested in this game anyway. Colorado Rockies home runs at home and away. Okay, these are the years 2000.
That the person throw the ball and the bat throw it in the air, or there's a person behind him catch the ball.
Yes.
If the bat hit it and go away, he have to run to it and catch it.
طيب okay, let's calculate the first question over the 10-year span. This is 10 years 1 2 3 4 5 6 7 8 9 10. Okay, 2007 from 2007 up to 2016. Okay, over the 10-year span, how many more home runs did the Rockies score in their home ballpark in Denver than at other ballparks? Again, over the 10-year span, how many more home runs did the Rockies score in their home ballpark in Denver than at other ballparks? طيب, who can answer? We should, by the way, add all of these 103 plus 92 plus 98, all of these minus these to see that to find the answer.
Home will be greater.
Of course. Look here. The answer is 1020 minus 738, which is equal to.
يعني مجموع الهوم كله 1020.
Yes, these are at home. 1000 at home minus 738 away. Okay, which is equal to 1020 minus 738. It is equal to 282 more at home. طيب, this is the answer. Are you writing?
Teacher, I finished.
طيب خلص, بدناش نكمل السؤال. خلينا نروح على آخر subject. فكرت سؤال فيه شيء important أنا. طيب, okay. The last thing, also energy is conserved in waves. Sami, what do you have?
No, nothing. I my hand.
طيب, go to page 124. Also, energy, waves have energy, by the way. Waves carry energy. Whenever in a wave move from one place to another, or when waves transferred or transformed, the same thing, energy is conserved. Conservation of energy in waves. By the way, waves are a result of vibrations. When something vibrates, means it goes, when anything vibrates, it goes back and forth. Waves.
Yes.
Waves.
And waves need a medium or an object to pass through it.
Okay, but not all waves, Rashid. Remember that electromagnetic radiation or light doesn't need a medium. Remember. Do you forget
But
this?
sound waves do need, because.
Yes, exactly. Sound waves need a medium. Or ocean waves.
That's how we hear other people.
Yes. So the vibrations that come from a wrecking ball smashing through a wall travel in sound waves. Okay, sound waves need a medium. In a sound wave or any other type of wave, energy passes. Okay, do you know that? You must know that, or remember that waves carry energy. All types of waves, sound, light, and so on. All waves carry energy. So In a sound wave or any other type of wave, energy passes through matter or medium without moving the matter to a new place. This is also an important point to know, that whenever waves carry only energy. They do not carry matter. For example, when sound waves travel through air, they carry only energy or sound energy, not the air particles. They just make the air particles to vibrate in their
No, I'm
place.
not understanding.
Okay,
I'm not understanding.
I mean, like, waves carry only what? Energy. They do not carry matter. For example, when sound waves travel through air, they carry only energy. They don't move air particles with them. So air particles do not move with the waves. Just the air particles vibrate. What is the meaning of vibrate? They go back and forth in their places. Again, look here. Look, this is, for example, sound waves. They are moving to this direction. Suppose that sound waves move. These are air particles, okay? These are the particles of air. Look, sound waves move like this. They carry energy. They do not carry these particles. I mean, the particles of air do not move from this place to this place. They just go back and forth in their places. Again, so for example, suppose that this is the source of sound. Sound waves move to this direction. Okay? Okay? They carry only energy. There are air particles, as you see here. There are air particles. When sound waves move through air, they hit the air particles, but they do not carry them. Sound waves do not carry, the waves do not carry air, just carry energy. The particles, when waves hit them, they go back and forth or vibrate in their places. Is it clear? Right. So the matter vibrates, meaning it moves temporarily, but it ends up back where it was. They do not move to something, to place, to another place. We can see this on the ocean surface with a floating object. Look here, figure, to understand it more, look at this ball. These are sound waves, ocean waves. This is the wave direction. Look, to understand it clearly, this is the wave direction. Notice that waves move, okay? But the ball stay in its place. Yani, for example, the ball do not move to the second side of the shore. Okay? This is waves move, they carry energy. The ball moves back and forth, but in the same place. Notice, look, ball's motion. Look, it go back and forth temporarily. But when you are at the beach, you may think that water moves. No, waves only move. They carry energy, but water itself does not move with the waves. طيب الآن we finish this. شو عندكم حصة بعدها؟ Hello?
Math.
Okay, we can see this. We can see this on the ocean surface with a floating object. An ocean wave passes. Look, ocean wave passes under the object, lifts it, drops it, and the object ends up back where it was. So it moves temporarily. That's why a surfer cannot catch a wave far out in the ocean. Once a wave breaks, matter is moved and energy is released. Okay, so a surfer can ride the wave when it breaks. energy is conserved as the breaking wave transfers its energy to the shore. That means when waves move, the energy is conserved. طيب. Okay. In this lesson, the last lesson, lesson 4, I want you to to concentrate that energy can change its form from one form to another or transform. I want you to concentrate also that energy can transfer from one object to another, okay? And you to distinguish between energy transformation and energy transfer, and to understand the law of conservation of energy. To understand the law of conservation of energy. طيب. Best wishes. Inshallah. Best wishes. See you inshallah. Goodbye.